so. All right, you ready? And tell me here, let me just ask straight up first. Did you guys do a method called grouping last year? Okay, so maybe this is not going to be foreign to you, but we still need a refresh, right? So let's look at example A. I want you to factor that completely for me. Factor it completely. So before we start anything, let's go down the checklist from yesterday. What do you look for first? Okay, 18. Well, first of all, they don't have X's in them, so get rid of that. What about 18, 9, 2, and 1? Anything they have in common? So we're all in agreement as a class, no GCF. How many terms? 4, not 3. So I'm not even going to discuss playing the multiply to this, add to this game. And our 8 is 18 a perfect square? No, 2's not. And I need 2 terms to do it. Difference of 2 perfect squares. So does everyone see right away, none of the 3 methods I discussed with you guys yesterday are going to work? All right, now we get to the 4th method, which usually, if you have 4 terms and no GCF, it's going to be what we call the grouping method. All right, if you remember from last year, grouping, first 2, last 2. You can also switch around the terms too, but usually in this class, I'm going to not be dirty about it here. It'll be first 2 and last 2. All right, I'm not going to be mean about it. Now we do GCF twice. GCF on the first set of parentheses, GCF on the second set. And hopefully some magic happens. So let's go first set. What can I take out of the first set right here? Here we go. Buckle up. Only got 12 of you. 10. Kate, what can I take out of the first one?
3.
Start bigger, bigger. Yeah, you can, but I want the big. Remember, I need the biggest. Good. 9. And what else do they all have in common in that first one? So take out X to the second. You always take out the one with the highest exponent. Everyone good? Would her 3 work? Yeah? I need the biggest, though, remember. Keep going. So that's good there. All right, what's left over now? If I take out a 9x squared for both of those, and when we say take out, I mean divide. Divide each of those terms by 9x squared. What do you got left for me? Let's roll with 12 now. Grant, what's left?
2x plus 1.
Good. Don't forget the 1 I talked about yesterday. It's not blank. It's a 1. Now we go to the second grouping. And remember, when you group, this is the biggest thing. When you group, what's inside your parentheses should be the same. That's your goal. Because if they're not, you can't group it.
Why would it be 2x squared?
Okay, ready? 18 divided by 9. Or it's not squared, right? It should just be 2x. One job. Act like you know what you're teaching. Okay. Thanks, Drew, for calling me out. I'll remember that, too. Be on the lookout. All right, I don't forget. Now, when I ask somebody for a GCF now, what's left in the parentheses better be 2x plus 1 as well. All right, and I know you're like, well, what the heck do I take out? Say what you want to say here, all right, because it's correct. 4.
1.
Marnie, go ahead.
1.
4. 1, go ahead, yep. Take out a 1. And look what's left. 2x plus 1. If there is something different in the parenthesis, that means you probably can't group it. Don't think it's always has to be grouping. It might not be. All right, we're not done. This drives me nuts. Kids just leave the answer like this. No, you're not done. Notice right now, I have a left side, I'll do in green, and I have a right side, I'm going to do in yellow. You have to take out what's in common now. And what is in common on both sides that I'm about to take out? 3. Sorry, I'll play. Stella? 2x plus 1. So I'm going to take out a 2x plus 1 from both sides. And in the second set of parentheses, you're going to tell me what's left after I take it from the left side and the right side. What's left here? 3 again, Stella? 9x squared plus 1. Good. Yes?
Does it matter if you switch the order of the parentheses?
No. Nope. Does not. Oh, I still got I got something here. Somebody deny me here.
Deny you? You still have to do the...
Oh, I'm not. Let me talk. Perfect. I see a perfect square here, here, and here. Can I keep factoring this? Oh boy.
No.
Don't fall in the trap. What's in the middle of the 2?
Oh,
It's difference, right? No, I can't go on. I know you see perfect squares, but it's got to be difference, subtraction. So we are done. This is as far as we can go right there using grouping. How we feeling? All right there? Ready to go on to the next one. Now look, hey, I try to throw you in so many traps. And then here's another one. Because everyone always sees 4 terms and thinks you have to group them. No, we're not ready yet. Don't forget what you learned yesterday. Where do we start everything? GCF. I don't care how many terms are showing, you start there every time. And oh, look at that. There is one. What is the GCF I should be taking out? 7. Ariana? 5. Good work. And when you take a 5 out, let me know what's left. Divide everything by 5 for me. Kate, go ahead. X. Q. I didn't remember. I didn't take an X out, right?
Yeah.
Go ahead. Keep rocking here.
Plus 2x squared.
Good work. Plus?
Plus 9x.
Plus what?
4.
4x plus, oh boy.
Plus
10.
Wait.
You're killing me. Use your calculator.
8.
8. By the way, and this just happened to be Kate here, I don't care what you use your calculators for. It's there. Use it. All right, you're going to get it on every test this year, the Regents exam, use it. If it's 1 divided by 1, I don't care. I'm not going to be that teacher. Oh, you shouldn't have to use your calculator for that. I don't care. It's there. You have it with you. Use the darn thing. We can still move on, though, right? All right, you know you're probably just not taking out a GCF at this level of math here, right? The big boy, big girl level. So let's now group what's inside here. First 2, last 2. All right, let me know what you want to take out of the first grouping here. X cubed plus 2x squared. What can I take out of this? 9. Harper? X squared. Good. When you take out an x squared, keep going. What's left?
X plus 2.
Good. And I didn't forget about the 5. I'll get to it at the end. So whoever I call on next, you better take out a GCF or I'm left with x plus 2 again. Right? Because that's what I want to be left over. Same thing inside the parentheses. 12. Here you go, Grant. What do you want to take out? So I'm left with an x plus 2.
I took out 4 and got x plus 2.
Good. You took out a 4, and we're left with x plus 2 again. And that's what you want. What's inside the parentheses should always match. If it doesn't, you probably couldn't group it from the beginning. All right. Finish grouping. Finish. 5. Emma, what's in common in both sides?
X plus 2.
Good. The x plus 2 I'll take out. And then what's left over when I divide each side by x plus 2 or take it out? 1, top of there. Max, what do you got?
X squared plus 4.
X squared plus 4. Remember, don't forget about it. Bring down the 5. How about this bad boy? Anybody want to challenge me on this one? Keep going. Keep going. No, yes?
No.
Why not?
Plus.
Difference, remember. It's got to be difference. So that is it. We're done. We're done. Okay, everyone good? Grouping. Yes.
Does it matter if I put the x plus 2 behind the x squared?
Nope. I don't care what you want to put the 5 out here. I don't care either. All right, as long as you got all 3 of them somewhere. Any issues? All right. I've been preaching here. What's inside the parentheses has to match, because you're going to see on this next one, sometimes it looks like grouping, but you can't force it. Okay, you can't force it. So I did this problem out. Here's what I had. I had 2x to the 3rd plus 10x squared plus 7x plus 21. I did some calculations and I made an error. Where did I make the error? Where am I incorrect? All right, so before we even look at my work, let's look over here. Any GCF? Any GCF? Nope. Okay, so I didn't take out a GCF because there was none. I noticed there's 4 terms, so I was like, this might be a grouping problem. So I grouped them, just like I've been told, first 2, last 2. What can you take out of the first grouping? I'm not even looking at the work. I'm just trying to do this like a problem that we just did. 3. Stella, what can I take out?
2x squared.
A 2x squared. Good. And everyone, I'm left with an x plus 5, right? All right, what would you like to take out of the next one? You can take something out of the next one. Kate, what can I take out of the next one?
7.
A 7. And I'm left with now x plus 3. See any problems? Yeah, you don't force grouping. That's my explanation here with this problem. All right, this is what I want you to get out of this problem: is you can't force grouping. If these two are not the same, we cannot group. All right, so the problem is right here, or actually step before, right here, no common, no GCF to take out. Okay, no GCF. So does everyone see? I don't want you to force it. I do not want you to force it. If it's not there, it's not there. Okay, we can't factor it. Are we all good? Make my point. Don't force grouping unless it's there. All right, new type of problem coming up. Prove the following identity. So let me talk, forget about the problem. Let's talk about what am I asking as far as the directions go. Pick a side. And what do I mean by a side? The equal sign is separated into a left and a right side. Pick a side and make it look like the other side. All right? So pick a side and make it look like the other side. That's as simple as I can put it. Okay? So we have an equal sign. We are going to make a class decision right now to work on the left side or the right side only. We don't go back and forth. We work on one side only, and hopefully our math ability is strong enough that eventually, I don't know what step it'll be, but it'll look like the other side. All right, that's our goal. There is one side in particular I'd like to work on because of the topic today. Can we work on the left side and hopefully make it look like the right side? All right, so that's what it means with prove the identity. Pick a side, do whatever you think you need to do mathematically on it, and then hopefully eventually, if we're good at this, it'll look exactly like the right side, which we don't touch at all. We good? All right, I want to make sure this is organized because I don't want to be grading hot messes here. So to keep your work organized, I'd like you to draw a vertical line right where the equal sign is. And then you work on the side you think you need to work on. All right, so we said left side, right? Any GCF over there? Nope. How many terms? 4. All right, so probably a grouping problem. Maybe. We're not going to force it if it's not there, but so let's group this bad boy. All right, what do you want to take out of the first grouping we made? 2? We got Paige? What can I take out of that? X squared. Great work. And you want to keep going? What happens when you take out an x squared?
You get 3x plus 2.
Good work. 3x plus 2. All right, here's where I start getting worried here. Make sure you take out something in the next grouping where you get a 3x plus 2 with those signs. All right, make sure I can take out something where I get positive 3x plus 2. What do we think? 27 and 18. What can I take out there? 8, which, Gabby? Remember, I want the biggest one if you can.
9.
9, good. Just a 9?
9, yes. Just negative 9.
Negative 9. Hey, because here's why. Here's why. If Gabby tells me positive 9, what's negative 27 divided by 9? Negative 3, right? But what did I need? Positive 3. All right, I got to have the exact same. So that's why positive 9 won't cut it. It's got to be negative 9. And then I'm left with 3x plus 2. All right, somebody fit it. Does it? All right, stop. Does it look like my right side yet? Absolutely not. Not even close. Keep working. All right, what should the next step look like here? 7. Ariana? What's in common?
3x plus 2.
Yep. And then what's left over?
X squared minus 9.
Good. We're almost here. Hey, guys, take a look. Does the right and left look the same yet? All right, so we're not done. Keep going. That tells you there's still something that can be done. All right, so look in the 2 parentheses that we have. What could still be done here? 6. What could still be done, Ethan?
It's the perfect square for the...
Finally, right? It's a minus, so that allows me to do it. 3x plus 2 times x minus 3, x plus 3. Now does it look like the right side? All right, maybe not in the same order, but I don't care about that. All right, and then all you got to do at the end is, hey, look at me, check. I did it. All right. But I know some of you guys get sneaky on me. I've seen this in the past. Students, you still got to show me the work in between. Like sometimes like they'll show me some work and all of a sudden it magically changes into what I needed on the right side. You got to show me step by step how you got there. All right, don't try to fudge it on me. Identities, we all right? All right, I got another one of these just to make sure because one doesn't make it great. Ooh, we may be, even some of the studs in here might be a little concerned with this one. Okay, algebraically prove. So that tells me again, that's the same type of directions you just had. Get the left or the right side to look like the other side. All right, get one side to look exactly like the other, but you're only allowed to work on one side. So let's draw that vertical line down. All right, what do you think, kids? Which side do we want to work on? Left side, right? I don't know what we'd be doing with the right. We'd be here a while. Oh, wait a second, though. Any GCF? Any GCF there? No. And how many terms this time? We're only used to 4 for grouping. I guess it's time to redefine grouping. Grouping, even number of terms. All right, we need to step up our game here. We've been doing 4, yep, that's fine, but it can be even amount of terms to group. Everyone good? You can group with an even amount of terms because now, look, instead of doing the first 2, last 2, I'm going to make 1, 2, 3 groupings. All right, that's the level we're at right now. So if you have an even amount of terms with no GCF, you can group. All right, rule still applies though. Whatever's in the parentheses has to be the same all throughout. So first one, what do you want to take out? What's on GCF in that first grouping? 2. Go ahead, Paige. What can I take out?
X squared.
X squared. What's left?
X squared minus 1.
Okay. I'm hoping, crossing my fingers now, when I go to the next 2 groupings, I get x squared minus 4 left. Hopefully. All right, what do you want to take out of the next grouping? The 5x cubed minus 5x. Take your time here. 8. Gabby, what do you want to take out of here?
5x.
Yep. And magically, what's left?
Wait, is that a 4 or 1? The first one. Would it be?
Oh, I don't know why it's. Who told me 4?
Nobody said 4. I said x squared minus.
Oh, did you? Did
Yeah,
you?
I
We'll have to
did
go.
not look at my paper.
We'll have to go back to the tape and look at that, huh? X squared. I'm on fire today. Go ahead, Gabby. And now I'm going to be left with n.
X squared minus 1.
1. God, that fires me out making these mistakes. Next one. What can I take out? 10. Kate.
6.
Yep. And that's it, right? You want which type of 6? Positive or negative? Good. Take out a negative 6. And I'm left with x squared minus 1. I take a peek over, not even close to what I need. So keep going. Keep grouping, right? Even though there's 3, the rules stay the same. I'll slow it down now. 7. Ariana, ready? What's in common in all 3 that I can take out? Okay, ready, everyone? I'm going to take out an x squared minus 1. And whatever's left over, you put in the next you don't have 3 parentheses here. I still have 2. Now you write everything else that's left after you take out an x squared minus 1 from each of those. All right, so nice and slow. What's left after I take that out? 4. Marnie?
For what? Sorry.
Okay, I'm going to take an x squared minus 1 out of each of these.
Oh.
So I need to write what's left. So what's left?
Oh, x squared plus 5x minus 6.
There you go. Good work. Okay, take a peek over the right side. Still not even close. So that must mean I can still do some stuff to the left side, right? Okay, here's where yesterday takes over. You pick. You pick. Where do you want me to go here? Because we're certainly not done. There's still work to be done on those. 2. Paige, where do you want me to go?
Are we gonna like multiply to negative 6?
You want to do this one here?
Oh.
I don't care. I'm just. We could. Ready? Let's do this one.
Or let's just do difference perfect squares first because I forgot about that. That's easier. It's in the front, so we'll do it first.
Okay. Whatever floats your boat. I'm not gonna fight it. X squared minus 1. That's difference of two perfect squares, right? X squared and 1. All right. What do you get when you do difference of two perfect squares? I know opposite signs. I learned that pretty well yesterday.
X and 1 and X and 1.
X and X, and then the square root of 1 is just 1, 1. Ooh, okay, I'm starting to look like the right side, right? But somehow, I don't know where this is going to come into play, that X plus 6. Ooh, maybe we can do something in the other parenthesis, right? Yesterday, we haven't talked about this one today yet, but we did a lot yesterday. How many terms? 3. Number out in front is 1, so we're playing the game, right? Numbers that multiply to -6, but add to 5. So I'll let you guys think about that. Whoa, relax. Numbers that multiply to -6, but are going to give me 5. This is always a tough one because you got 6 and 1 and 3 and 2 to play around with. Hey, wait. Listen to what I just said here. You have 6 and 1 and 3 and 2 to play around with, right? But you know what it should be already. You know what the answer is. What's over here? A 6. So you know it's got to be some combo. That's at least what's great about these problems is you know what you should get at the end. So there's no way it should be 3 and 2 because there's no 3 and 2 on the right side. And that should be the answer. So it's definitely 6 and 1. Now I'm going to turn it over to you guys. What about the signs? 8. Gabby, signs?
-1 and +6.
Good. Now we just have to clean it up. How do I get this bad boy there? Oh, I have 2 of these, right? And then if I rewrite it the fancy way, it's squared, right? And then I have +1, +6. Whew. All good. So proving it, you pick a side, work on it until it looks like the other side. And obviously for us, you pick the side that can be factored. Any questions before I go on to something a little different to end the class? We're good? All right, guys, I'm going to have a problem here. Here we go. I got a problem. Where are you going to start? What are you going to start thinking about right away when you're asked to factor? GCF. Anything, guys? All right, that's off the table. How many terms? Ooh, 3. And what's the number out in front here?
6.
Yikes. So I can't go multiply to 5, add to -13. Everyone see why? It's got to be a 1 there. How many terms are there?
3.
Not even, so I can't group. Is this difference of two perfect squares? We're toast. Nothing I've shown you is going to work here. Until now. We're going to change 3 terms into 4. So we can group. Okay? So that's on my plan. Here's what I'm going to show you right now. Right now you're correct. We have 3 terms, but I'm going to show you how to turn it into 4 so you can group them. Ready? First step, to turn it into 4 terms, you multiply the A and the C value together. So the first and the last together. So 6 and -5. We end up with -30. So I multiply the A and the C, and I end up with -30. Here's how we're going to turn it into 4 terms. I'm going to keep the 6x squared, and I'm going to keep the -5. What I'm going to do with you right now is take that middle term and make it into 2 separate terms. That still give me -13x in the middle, though. So here's what you need to do right now. 2 numbers that multiply to what you just had, -30, but at the same time are going to give me -13 when I combine them. All right, so I'll let you write it off to the side. 2 terms that multiply to -30, but are still going to give me -13 when I combine them in the middle. So think about those numbers. You got a bunch for 30, huh? 130, 215, 310, 56. Ooh, there's a couple there that are going to be tricky. I've got 10, 3, and 15, 2 could both potentially work. But only one pair is going to give me negative 13. And give me negative 30. Think you guys got it? 15 and 2 are the ones. Make sure we put x's with them, right? Because I need 13x back. And how do I get a negative 13 now? Negative 15 and positive 2. Now look, hey, have I changed anything? Look, what do you get when you combine those? Negative 13. It's still the same problem. I just made 3 into 4. Because now what can we do? I'm done now teaching you. You know how to figure this out. It's grouping now. All right, it's grouping. All right, show me I taught you something here today. What do you want to take out of the first one? 6. Ethan?
3x.
A 3x? Good. What are you left with when you take out a 3x?
2x.
Good. 2x minus 5. Yep. Ooh, we did this one at the very beginning. I want to also get a 2x minus 5 back. So what's the only thing you're going to take out here? Ooh, 8, Gabby.
Wait, I think I did it differently. I put the 15 with the 5 and the 6 with the 2.
Oh, so you switched it?
Yeah.
Okay, that's fine. We keep going. I want you to keep going. No. Keep going. I'll call on somebody else.
Okay.
Keep going with your problem to make sure we still get the same final answer. Okay? Because that's fine. I should have brought that up too. 2. Doing it this way, Paige. What can you take out? 1? Yep. And you should still get a 2x minus 5. So I should be left with 2x minus 5 and 3x plus 1. How's that look, Abby?
I don't know if I did it right.
Okay, so I'll do it real quick here. X squared plus 2x, and then you did minus 15x over here, minus 5.
Oh, I didn't put the x with the 15.
Yeah.
That's what I did.
Yeah, make sure because they have to get 13x in the middle.
So 3x plus 1, yeah, then. I just forgot
Yep.
the x, yeah.
Okay, we're good. Good talk. Anybody else going? Before we get to this last one here? This is the last one, right? I want to make sure I wrote it in the correct order. Okay. What don't you like about it? I'm not a big fan of something right away. Yeah, can we put it in order? I don't like it with the squared, the cubed, and then the regular x. So let's put this in order first before we start doing any damage. So negative 8x cubed plus 60x squared plus 32x. Yeah, I like this to have this in order because if it's not, some of my rules don't work. All right, what are we thinking next? Hopefully you're not thinking about multiplying negative 8 and 32. We're not even there yet. You always start this journey GCF, everyone. GCF. They all have an x in it, so we can definitely take out an x. What about negative 8, 60, and 32? Biggest one. I know they're all even, so 2 would work. Is there anything bigger? 4, yeah. And also, I don't know about you guys, I'm not a big fan of that negative sign. I want to get rid of it as soon as possible. So we all right taking out a negative 4 so I can get rid of that? That just worries me there. All right, divide everything by negative 4 now. Divide everything by negative 4. What am I going to start out with? 2x squared minus now, right? Because 60 divided by negative 4 is a negative 15x. And then 32 divided by negative 4 gives me that negative 8. And probably what would we be able to do inside? Keep going, right? So I'm going to let you guys try this. Leave the negative 4x out there till the end. What I want you guys to do right now is turn this into 4 terms so you can group it. All right, don't even worry about the negative 4x. It's done. We're not going to touch it again until the answer. So multiply 2 and negative 8 and see where you can go from here. All right, see what you guys can do. Just focus on that parenthesis and trying to group it. Turn it into 4 terms, then group it. So you're looking at two numbers that multiply to negative 16, but add to negative 15. Yeah, Max, what do you got? Say that one more time.
Why did we not put exercise 6 in order? Like we did with 8?
Because I noticed right away that I could group it. So that's why. Because here's the problem. Like, say I tried to combine like terms. Now I'm not probably going to have an even amount to group. Okay, so I want to try to always, even though I could probably combine some, if I have an even amount, I want to try to do that. Okay. And we did stuff. What I mean by in order is I really like the largest exponent and stuff. Okay, that's what I mean by in order. All right. We have negative 16x plus x in there. And again, if you reversed it, fine. We're still going to get, if you had x minus 16x, that's fine. We should still get the same. Questions on how I got this before I group it? All right, let me group it now. Take out a 2x, right? I'm left with x minus 8. And I'm going to have to take out a 1. Be left with x minus 8. So there's the first part of grouping. Make sure you finish it. Don't leave it like that. So I have x minus 8, 2x plus 1. And of course, don't forget the GCF we took out at the beginning. All right. Questions? Okay. Why don't you try them out on your own now? Keep going. You guys know where the answer key is. Please don't. I never understand it where kids do a whole bunch of problems and they don't know if they're right or wrong. All right. Try it out. Try them out.